This is after the first term. Today is day 5 of the chemistry class, chapter electrolysis. Is that okay, all of you? Okay. Now,
Yes, sir.
Yes, sir.
now, today, the next example of electrolysis that I would like to explain all of you is electrolysis of aqueous copper sulfate solution using copper electrodes. And this electrolysis of aqueous copper sulfate solution using copper electrodes you will find in your textbook on page number 116. Page number 116. Okay. You may keep your books open if you want to, otherwise, you may leave it. Okay. Now, during the electrolysis of aqueous copper sulfate solution using copper electrodes, which is also an example of electrorefining, okay, the electrolyte is aqueous copper sulfate and it is added with few drops few drops of dilute sulfuric acid. Few drops of dilute sulfuric acid is added to this aqueous copper sulfate solution to increase the conductivity of this copper sulfate solution, so that it becomes a better conductor. It is a conductor, but it becomes a better conductor after the addition of few drops of dilute sulfuric acid. Now, in this electrolytic mixture, the ions present, let me first discuss the ions present. Ions present, copper sulfate solution, aqueous, it will dissociate to give Cu plus 2 ion and SO4 minus 2 ion. Getting it? So copper sulfate solution is providing copper ion and sulfate ion, and at the same time we have added dilute sulfuric acid. So this dilute sulfuric acid is going to provide me with, I'll write it over here, dilute sulfuric acid will provide hydrogen ion and sulfate ion. Okay. So the ions which are present in this electrolytic mixture are copper ions, sulfate ions, and hydrogen ions. Now, when the switch is put on, all the positive ions will go towards the cathode. You can see in the diagram over here. They are going towards the cathode. Okay. Please note that, boys, the color of aqueous copper sulfate solution is blue. It is blue. Now, here in the electrolysis of aqueous copper sulfate solution, the electrodes are made of copper. The cathode is made up of pure copper. Pure copper strip, and the anode, it is made of impure copper. That is how this is also called electro refining of copper. Okay. Now, This is the diagram you must remember. There is a diagram in your textbooks also. So now reactions happening at the cathode and anode. Now at cathode, what will happen? The copper ion, the copper ion and the hydrogen ion will go to the cathode. The copper ion and the hydrogen ion will go to the cathode. Okay. Between copper ion and hydrogen ion, the position of copper ion is lower in the electrochemical series. Therefore, at the cathode, copper ion will discharge. Copper ion will discharge. At the cathode, from the solution, copper ion will go to the cathode and it will discharge by accepting two electrons, by taking in two electrons, and it will form copper metal. It will form copper metal and deposit on the cathode. Deposit on the cathode. Okay. Are you getting it? Are you getting it, boys?
Yes, sir.
Okay.
Yes, sir.
Whereas on the other side, at the anode side, the sulfate ions, all the sulfate ions will go to the anode. All the sulfate ions will go to the anode, but the sulfate ions will not discharge. The sulfate ions will not discharge. The reason is the anode is made of copper, which is an active electrode. The anode is made of what? Anode is made of what? It is made of copper, and
Impure
it is
copper.
an
Copper.
active electrode. It will not.
Impure copper.
Yeah, it is an impure copper. It is an impure copper block. It is an active electrode. That is why it will prevent. It will not allow this sulfate ion to discharge. Are you getting it? So what will happen? The copper metal, the copper metal, the electrode, the anode made of copper metal will produce ions. So at anode, the copper metal on the anode, it will lose two electrons. It will lose two electrons and forms copper ions, and then it enters into the solution. Are you getting it? Are you getting it? Because copper
Yes,
is an
Yes,
sir.
sir.
active electrode. So this is one wonderful thing happening over here. It is one wonderful, fantastic thing happening over here. At the anode, copper ions are produced. At the cathode, copper ions are discharged to form the copper metal. So you can see, over here that at the cathode, copper ion is lost. At the anode, copper ion is produced, which means as long as we continue with this process, the blue color of this electrolytic solution will remain. It will remain. It will not get discharged. Okay. So for the loss of every copper ion at the cathode, a copper ion is generated by whom? By the anode. So this is how the question will be asked. They will ask you, during the electrolysis of aqueous copper sulfate using copper electrodes, okay, what are the electrodes made up of? What are the electrodes made up of? Tell me.
Yeah,
Copper.
copper, pure
Yes.
copper, impure
Pure
copper.
copper and
Yeah.
pure
So you
copper.
have to be precise in the answer. You have to say the cathode is made up of pure copper strip, pure copper strips, STRIP strip. Okay. And the anode is made up of impure copper block, impure copper block, like this. Okay. This is what you have to remember. Which means the the impure copper block is getting purified and the copper metal is getting slowly transferred to the cathode side. Are you getting it? So that's why this is also an example of electro refining. You have to keep in your mind. Okay. The next question they can ask you is, write down the reactions happening at the cathode and anode. So you have to write this at the cathode, this equation. At the anode, you have to write this equation. Okay. Are you getting it?
Sir, so
Yes.
what? Excuse me, sir.
Yeah.
So
Ask
what
me.
Yes,
is the
sir.
use
We are
of this?
getting it.
So
What
where
is
is
it?
it used?
Which one? This one.
This experiment.
Yeah, this
The
experiment is
experiment.
this experiment is used to electro refine copper metal. when copper metal is extracted from the ore, no,
Yes,
are you
sir.
getting it? It is
Yes,
extracted
sir.
and copper metal is obtained in blocks, in the form of blocks or boulders. Okay, it is transformed into cylinders which are impure. Which are what? Impure. And for the
Impure.
purification, it is connected to the anode, and a very thin, like paper strip, is made the cathode made of copper, and then current is passed. DC current is passed through the electrolytic solution, which is made up of acidified copper sulfate solution, and then purification happens. When time goes by, the size of the cathode will increase. It will increase, and when time goes by, the size of this anode will decrease slowly, because there is transfer of matter, transfer of copper metal from the anode to the cathode. Am I clear?
Yes,
Yes,
sir.
sir.
Very good, very good. Now, all the impurities present on the impure copper block, they settle down at the bottom over here in this container electrolytic cell, and it is named as anode mud. It is named as what? Anode mud. Am I clear? So they will ask you,
Sir.
why does the blue color of copper sulfate solution during the electrolysis of aqueous copper sulfate solution using copper electrode does not fade? They'll ask you, why doesn't the blue color fade away? You must answer. You must give the answer in this way. The blue color doesn't fade away because for the loss of every copper ion at the cathode, a copper ion is generated at the anode. So, as long as copper ions are there in the electrolyte, the blue color will be retained. Am I clear? Am I clear?
Yes,
Yes,
sir.
sir.
Okay,
Yes,
wonderful.
Yes,
sir.
sir.
Okay, now let us go to
Yes,
the
sir.
next part. This was on page number 116. Okay, now I will go to the next example. Example is electrolysis of aqueous copper sulfate solution using inert electrodes. When I say inert electrodes, here in this example, I am using electrodes made of platinum. Look at the wonderful diagram. Okay, beautiful diagram. Though I did not draw it. Okay. Now, the
Sir,
cathode. Yes,
sir.
yeah.
So I cannot see any diagrams in the screen, sir.
I am sharing the screen. The screen is shared.
No,
Is
sir,
it?
it is not showing, sir.
Why isn't it showing?
Your internet is very
Internet
slow. So
problem.
his internet is slow. So his net is
So
Oh.
slow.
we can see.
Who?
Yes, sir.
Who?
No, guys.
So we can see.
Chawang.
Active
Chawang cannot see.
and enter.
Chawang. Chawang.
So I
Sound clock.
Huh?
I can see.
Who?
So
Chawang
I
you can
can
see
see.
no. Who's the boy who cannot see?
Yes, sir.
Huh?
Sankal.
Sankalp.
Sir,
Sankalp.
sir,
Sankalpa.
Some call.
Sankalpa.
Oh, Sankalpa. Like,
sir.
what net are you using, my dear?
Idea.
Huh?
Zero,
Net
sir.
side.
Zero.
No, you should use internet which is slightly faster, or you should
So
have a data plan which is got more GB. I don't know what is GB,
No,
but
sir.
yes,
Gigabyte.
Sir,
Gigabyte.
yeah.
sir,
I'm not.
sir, tower is.
Oh, tower
Sir, the
is
tower is
Terabyte.
near my house.
tower is. Oh,
The
that's
near my
right.
house, sir.
That's right. That's right.
Oh,
When the tower is near a house, no, then it is not possible to get the connection.
activate flight.
Yes, sir.
Activate flight.
Very true.
Not deactivate.
The quality
sir,
is
idea
raining, sir.
internet.
Other days it used to be
Yeah,
like
other days
fast,
it
but
is. But today, you look outside, the weather is so foggy.
sir, raining.
It is raining.
Yes,
Yes,
sir,
The
sir.
weather
raining,
is
sir.
So it's raining there.
Yeah,
Oh,
it's raining here.
I thought it's raining in
Sir,
Sikkim.
raining, sir.
I thought it's raining in Sikkim only.
I'm in Namchi right now.
Huh?
I'm in Namchi, no?
Yeah.
It is raining here
Sir,
also.
I am in Adivara,
Namchi.
sir.
So which place? So which place, Namchi?
I'm in Namchi. I will tell you the place later on.
So Darshan stays in Namchi.
Darshan. I'm just below Namchi Public School. That Gaon is there, no?
So Darshan.
There
So
only.
Darshan has a
Dawson
hotel.
is in there, Bonjang. That's 2
Bonjang.
hours.
Bonjang is quite below, far away. Anyway, leave it. Now let's come back over here. At the cathode, what was happening? The cathode is negative terminal connected to the battery, and at the anode, you can see platinum anode. Okay, now In this electrolysis of aqueous copper sulfate using inert electrodes. Electrodes are made of platinum or carbon. Okay, you can use it either platinum or carbon, anything. Both are inert. Okay, now
The page
eh,
number?
it's on page
The page
number.
number?
Diagram is not there for this. It is on page number 116 and 17. Okay, it is on page number 116 and 17. Diagram for this is not there, but I am giving you the diagram from my side as a bonus for you. Okay, are you getting it? This I'll be sending you in the WhatsApp group also. So nothing to worry. Just now your work is just to pay attention. Okay. Now the ions present. I'll write down the ions present. Ions present. Aqueous copper sulfate solution. It is going to produce copper ions and sulfate ions. And we normally add dilute sulfuric acid, few drops, which increase the conductivity of this copper sulfate solution. So dilute sulfuric acid is going to produce hydrogen ions and sulfate ions. Okay, so these are the ions present in this electrolytic mixture solution. Okay, now when the switch is put on, the copper ions and the hydrogen ions will go to the cathode. They will go to the cathode, whereas the sulfate ions will go to the anode part. Okay, now let us see what happens at cathode. At cathode, at cathode, the copper ions will go, hydrogen ions will also go over there, but between copper and hydrogen will not discharge because its relative position in the electrochemical series is higher than copper. Therefore, copper will discharge. So, at cathode, copper ion will take in two electrons. It will take in two electrons from this cathode and will become copper metal and deposit on the cathode. It become copper metal and deposit on the cathode. Okay. Now at the anode side, the sulfate ion will go to the anode. Now here, since the anode is made of platinum or carbon, which is an inert electrode, which is an what? Inert electrode.
Inert.
Therefore, it will allow the discharge of sulfate ion at the anode. So what will happen? It should allow the discharge of sulfate ion. But please note that we have used water because we have used water to prepare the solution of copper sulfate. No, so water is also there. So please note that water provides hydrogen and hydroxyl ions. Now there are two negatively charged ions in this mixture. So sulfate is there, hydroxyl is there. Now both sulfate and hydroxyl go to the anode, which is made of platinum. Now there is a war. There is a war between hydroxide and sulfate to discharge. But when we look at the electrochemical series, we see that the position of hydroxyl is below sulfate. That is why sulfate will not discharge. This sulfate will not discharge. So who will discharge, my dear boys? Who will
Hydroxyl
discharge?
ion
Yes,
Hydroxyl
hydroxyl will discharge. So
Hydroxyl ion.
at
is
anode,
the weaker.
hydroxyl will discharge. So like I have told you in the previous class, during the electrolysis of acidified water, whenever there is a case of hydroxyl ions discharging, remember you have to use four hydroxyl ions discharging by losing four electrons to produce two water molecules and one oxygen molecule. So oxygen gas is formed at the anode in this case. Okay, so this is the reaction happening at the anode and this is the reaction happening at the cathode. Now in the beginning, the color of this solution is blue. It is light blue. But with time going by and the process continuing in the forward direction due to the passage of direct current through this electrolytic solution, there is loss of copper ions from the solution. Therefore, the color of this electrolytic mixture slowly fades away. It slowly fades away, and the time comes when the solution slowly turns into a colorless solution, which means that the solution does not contain any copper ions. As long as the copper ions are there, the solution is blue in color, but when all the copper ions are discharged at the cathode, then the color of the solution, the blue color of the solution, it fades away. Am I clear? Okay. So this, whatever I spoke just now, this will be a part of your question. Why does the light blue color of the aqueous copper sulfate solution fade away during its electrolysis using inert electrodes? Because for the loss of every copper ions is not generated by the anode, because the anode is made of platinum or carbon, which is an inert electrode. Am I clear? That should be the answer. And you should know, you should be able to write down the reactions at the cathode and the reactions at the anode. Am I clear? Okay. Now let us go to the next part of this chapter. Okay, let us go to the next part of the chapter. Page number.
Sir.
Yes.
Excuse me, sir. Sir.
Yes. Yes.
Sam Pratham, sir.
Sir, is this?
Is this? Pratham, where are you?
So from
Sir, is
electrolysis
this an?
acidified water.
Yeah. Electrolysis of what?
So could you please explain this reaction at the cathode and anode once again?
This one only? This one only?
No, sir. Electrolysis of acidified water using platinum electrode.
Were you there in the previous class?
Yes, sir. I
You were
was there.
Okay, I'll explain it once more. Okay. For Pratham. Okay, here we go for Pratham. Electrolysis of acidified water. Okay. I'll explain electrolysis of acidified water for Pratham. Okay. Others also pay attention. Okay. Others also pay a lot of attention. Otherwise, you will get jeopardized, just now. You will get lost. Okay. Now have a look. Acidified water. Electrolysis. Electrolysis of acidified water. This water contains dilute sulfuric acid. Okay, now I'll draw a beautiful diagram. Okay, a beautiful diagram. I'm very good in drawing, boys. Okay, so I take a container. In this container, I fill it with water containing dilute sulfuric acid. Okay, and I will take two test tubes, two glass test tubes. Okay, and fill those two glass test tubes with this water containing dilute sulfuric acid and turn them upside down over here. Turn them over here like this. Turn them upside down in this manner. Okay, turn them upside down like this.
So
Others are in this only reaction at the cathode and anode.
Yeah, that's what. For that, I have to explain you this diagram. Then I'll explain. No?
first, you fill the test tubes, no?
Yeah, that
Or
story.
it's empty.
Don't go so much in detail.
Sir.
These test tubes contain.
The test tube is empty.
No, it is filled with
Oh.
dilute sulfuric acid. Okay, it is filled. It is filled right till the brim, right till over here, right till the end over here. Okay, and it is inverted and it is clamped at the side with the help of clamp stands. Okay, and then below this, we place platinum electrodes, and connect them to wires. Okay, connect them to wires like this, and then over here we can put the battery like this. Okay, and complete the circuit, positive, negative. This becomes plus, this becomes minus, this becomes the anode, this becomes the cathode. Am I clear?
Cathode.
Okay, now this acidified water contains dilute sulfuric acid, so the ions present are hydrogen, hydroxyl, and sulfuric acid provides two hydrogen ions and sulfate ions. So these are the ions which you will find in this electrolytic mixture solution. So we can write them down one each over there. H plus is there. Okay, OH minus is there, sulfate is there. Okay, now when the switch is put on, current starts to flow, DC current starts to flow through this electrolytic mixture, and the cation, all the cations over here, the cations are only hydrogen, they will go to the cathode, and hydroxyl and sulfate will go to the anode. Are you getting it? Now, at cathode,
Yes, sir.
Pratham, I hope you are there. At cathode, hydrogen ions, let's take four hydrogen ions will gain 4 electrons, and it will form 2 molecules of hydrogen. Okay, I am jumping the 4 steps over here. Instead of writing 4 times, I am writing in one shot only over here. 4 hydrogen ions at the cathode will gain 4 electrons to form 2 molecules of hydrogen gas. So hydrogen gas is formed and it goes up over here. It goes and gets collected over here. There is hydrogen gas getting collected over here. Okay, 2 molecules. Whereas at the anode side, on the anode side, what happens? I'll tell you. At the anode side, both hydroxyl and sulfate go to the anode, but sulfate will not discharge. Sulfate is not discharging because its position is higher in the electrochemical series. Okay, therefore, instead of sulfate, hydroxyl will discharge because its position is lower. So again here at the
I didn't
anode,
understand.
huh?
Sir, I didn't understand.
What this part?
So that discharge.
Discharge means losing the charge. Discharge means to lose the charge either by gaining electrons or losing electrons. Negatively charged ions, they lose electrons. Positively charged ions, they gain electrons. So here, between hydroxyl and sulfate will not discharge. Only hydroxyl will discharge because its position is lower in the electrochemical series. That's why only hydroxyl discharge. That's why at the anode, as I have told you, 4 hydroxyl ions will discharge by giving away 4 electrons to produce 2 water molecules and oxygen gas molecules. So oxygen gas molecule which is formed over here, it bubbles up and goes and gets collected over here. Okay, so that is it. Electrolysis of acidified water using platinum electrodes. Done. Okay. This was something which I had explained in the previous class. Today again I have explained it and Pratham has understood it very nicely. Isn't it, Pratham? Okay.
Yes, sir. Sir, thank you.
Now we move ahead to the next topic in this chapter, which is called electroplating with nickel. But before going to electroplating with nickel, my dear boys, if you turn to page 118 over there, in your textbook, you should be having a textbook. In your textbook, you will find on page 118 electroplating of metals. The definition is given over there. Okay, it is the electrolytic process of deposition of a metal which is superior. Like examples are chromium, gold, silver, nickel. These are superior metals, and if you deposit these superior metals on baser metals like iron, copper, brass articles, then it is called electroplating. Okay, so definition you can underline and learn it from the textbook itself. Okay, it is a very wonderful, fantastic definition over there. Then what are the reasons for electroplating? The basically important reasons for electroplating are it prevents corrosion or rusting, and at the same time it makes the article look very attractive. Like a brass article, it can be electroplated with silver or maybe with gold. Okay, so these are the important reasons for electroplating that you have to underline and learn it from the book itself. Okay, now the next thing over there on page 118 is conditions for electroplating. What are the conditions? Number 1, the article to be electroplated is always made the cathode. Okay, remember that. It is always made the cathode. That is point number 1. Because there is always transfer of metallic ions from the anode to the cathode. That is why the cathode must be the object you are plating. Okay. Point number 2, the metal to be plated on the article is always made the anode. That is point number 2 over here. Okay, and the next point is the electrolyte must be a solution containing the metal you want to electroplate, or you want to coat on the cathode. Okay. There are two more points which I have not mentioned over here. Point number 4 and point number 5. Point number 4, according to your textbook, says that you should provide a low current, a very small current, maybe 1.5 ampere. Okay, low current should be passed through the solution, through the electrolytic mixture for a longer period of time. And the fifth point is DC current. You should always use a DC current in order to electroplate articles which are made as the cathode. Okay, so now we will go to the first example of electroplating, which is called nickel plating, which you can see over there. Okay, so this nickel plating I will explain you with the help of a diagram, which I will draw just now. Okay, now have a look. Nickel plating. For nickel plating, the diagram, we take a container as usual, an empty container, and fill this container with a solution which is nickel sulfate solution. Okay, now on the anode side, we tie up over there the anode, which is made up of a block of nickel, thick block of nickel metal. Okay, thick block of nickel metal, and then I connect it to a switch, and then I connect a battery like this. Okay, plus minus. Okay, then on the other side I can connect, I can take a nail, nail, iron nail, make an iron nail, or a screw. You know what is a screw? Okay, this is screw. I can take, this is the anode, it is made of iron screw. Okay, that is iron screw. Okay, now it has to be electroplated with nickel so that it does not rust. Okay, now this nickel sulfate solution contains the following ions. I am writing down over here. Nickel sulfate solution dissociates to provide us with nickel ion and sulfate ion. We have used water to prepare the solution, so water is going to provide us with H plus and OH minus ions. So these are the ions present in this electrolytic mixture. So I'm going to write them down over there very happily. Ni plus 2, then H plus 1, then SO4 minus 2, and OH minus 1. Okay, now when the switch is put on, current, as I've told you, flows in this direction, electrons flow in this direction. Okay, all the electrons come and accumulate on this iron screw, which is the cathode, which is acting as the cathode, and current comes this way carrying the positive charges and accumulate over here on the thick block of nickel. Okay, and then this is acting as the anode. Okay, now the movement of the ions begin. The nickel and the hydrogen ions will go to the cathode, whereas the sulfate and the hydroxyl will go to the anode. Now the discharge will begin at the cathode. At cathode, between nickel and hydrogen ion, there is a tussle. Who one will discharge? But according to the electrochemical series, it has been found out that nickel discharges because its relative position in the electrochemical series is lower than hydrogen. That's how nickel ion, it takes up 2 electrons and it becomes nickel metal and deposits on the surface of this iron screw. Okay, whereas on the other side, on the anode side, both sulfate and hydroxyl go over here, but none of them will discharge because nickel is an active electrode. It is an active electrode. It will not allow these two fellows to discharge. These two fellows will remain in the form of ion just below the anode. Okay. Rather, what will happen? At anode, the nickel metal which is there on the surface over here, the nickel metal will lose two electrons. It will lose two electrons. After losing the electrons, will move up like this. It will go up towards the DC current battery. Okay, it will lose two electrons and it will form nickel ions and jumps into the solution over here. Okay, it forms nickel ions and enters the solution. So one nickel is depositing over here, one nickel ion is being formed. So if you continue this process for a long time, say half an hour or 1 hour, we will find that there is a very thin, nice, smooth deposit of nickel metal on this iron screw. Now this iron screw will look shiny, it will have a shiny appearance. It will not be rusted or it will not undergo the process of corrosion. Okay, so this nickel plating has been explained along with the diagram in your textbooks on page number 119. Okay, so there on page number 119 you can get the electroplating with nickel, very nicely explained over there already. Okay, and the questions are reactions at the cathode, you should be able to write down. Reaction at the anode, you should know the diagram, you should know what the anode is made up of, you should know what the cathode is made up of. Cathode is a baser substance, baser article, and the anode is a superior article which is used to plate the baser article. Okay, so this much is clear, I think, for all of you. Nickel plating. Okay, is it clear to all of you now?
Yes,
Nickel plating is
sir.
clear. Okay, now after this, it is already 11:19, so I would like to stop my class over here, but do not go away. I'll have to record your
Yes, sir.
attendance digitally. Okay, remain hanging over there only.
So you'll
Yes,
so
sir.
you'll send our marks.
I will,
Yes,
yeah, I will send your marks very happily, don't worry. Okay, but before that, let me take the attendance. What class do you have next period?
Economic.
Group 3.
Economics, group 3. Okay, very
Group
good.
3.
So group
Very
3.
good. So there are only 82 boys over here present in this class today. The remaining boys are not there. Therefore,
It's the highest.
huh?
It's the highest of
Sir,
the.
It is the
today
highest.
is the highest, sir.
Yes, sir.
Wonderful.
Today's highest of.
Yes,
Today is the
sir.
highest.
By this time, it will be 60
Okay.
boys, something like that.
Okay, now you all
60
can
boys.
you all can leave the class. Okay, you all can leave the class now. I'm
Thank
leaving
you,
the
sir.
class. Thank you. Have a nice day.
Yes, sir.